6.4b, using right triangle trigonometry. We're going to derive basic trig identities and solve right triangles using trig functions. So the inverse trig functions. Find the approximate value for angle A in each of the following. So what if you have to find that you're given the ratio of the sides, we have to find the angle. So tan A, we have to find the angle A. So you're going to rewrite that as A equals tan negative 1 of 0.8391. And then on your calculator, you do the second tan button. On most calculators, it's second tan, or the inverse tan, second tan. Punch in the number, and you should get an angle in degrees. What do you get for your angle on this one, Shatise?
I get like around 40.0000.
Yeah. He got 40.0000. So we'll just call that approximately 40 degrees. Do the sine of inverse sine of 0.3581. See what you get. Anybody, what'd you get? Somebody besides Shatise. Yeah, Ella. 9 what? Okay. So it's 20.9835. So we'll round that to approximately 21 degrees. Alright. So everybody understands. Now we're finding the angle rather than the ratio of the sides. Capital letter is an angle. All right. So an example. We have a familiar right triangle is a 3, 4, 5, as shown. Find the measures of angle A and angle B. Okay. So let's take angle A. The sine of A would equal to what ratio? What would the sine of A equal to? Abby? Yeah, so what would that be? What numbers would that be?
4/5.
Yeah, it'd be 4/5. So we've got the sine of A equals 4/5 is 0.80. Right? So now we have to do the inverse sine of 0.8, and you're going to get A equals, let's round it to the nearest tenth. How many degrees? A equals what? Julia?
53.13.
53.1. The nearest tenth would be 53.1 degrees. Questions? Okay, so we've got A. Now, there's an easy way we could find B. What would be the easiest way to find B? Shatise?
You do 90 minus 53.1.
Yeah, we could do 90 minus 53.1. But in the spirit of using trig, let's find angle B. Let's use cosine. Cosine of B equals what ratio? Madeline. What? Okay. Cosine is what do we do in terms of sides, Nina? Adjacent over hypotenuse. What's the adjacent?
4.
Yeah, it's 4. So it's 4/5. So do the inverse cosine of 0.8. Cosine of B equals 0.8. Do the inverse cosine of that.
What do we round to?
Nearest 10. You hit second sine, or second cosine, put in the value. What'd you get? Yeah, 36. B equals 36.9 degrees. Does anybody need help with the calculator? I'll come over and show you how to do it. Anybody need help with calculator work? Everybody's able to get those values. All right. Now, in the right triangle with acute angle A, the sine of A divided by the cosine of A is the tangent of A. All right, we have to show why this is the case. So we can. It's kind of like a little proof. You don't have to provide reasons. It's so we have the sine of A over the cosine of A. Let's convert those to ratios. What's the ratio of the sine? What's sine of A? Shatice?
Sine of A is opposite divided by hypotenuse.
Yeah. So in terms of letters, what would that be?
O divided by H.
What?
O divided by H.
There is no O.
Oh, like in terms of the triangle?
Yeah.
Oh. So it would be A divided by C.
A divided by C. What would the cosine be? Lily?
It would be B divided by C.
It's B divided by C. All right, so we want to simplify that. So A divided by C over B divided by C is the same thing as A divided by C times C over B. Those cancel, and we get A over B, right? And we know in terms of A, the ratio of A over B is which trig function? See, Zach? Yeah, that equals the tangent of A. So we've just proven that. So if you have a problem like that, these are called trig identities, then plug in the ratio of the sides according to the triangle they give you and show it using the ratio of the sides. Let's do another one. We've got in a right triangle, acute angle A, the sum of sine squared A and cosine squared A is 1. Alright, we're going to refer to the previous triangle that we just used. And so we're going to, if I look at that triangle, then we've got we can use Pythagorean theorem, right? And say, and I know to use Pythagorean theorem because they've got sine squared A, cosine squared A equals 1. 1 is a perfect square. So that resembles the Pythagorean theorem. You just know from experience to do that, to use the Pythagorean theorem, because it has kind of the same format. So we would say in that triangle we've got A squared plus B squared equals C squared. And then we divide both sides by, we have to get the number on the right of the equal sign to be 1, so I would divide everything by what? What would I divide everything by? Jordan? Yeah. So we divide everything by C squared, so we got A squared over C squared equals B squared over C squared, not equals plus B squared over C squared equals C squared over C squared. So then we can change that to a over c squared plus b over c squared equals 1. Okay? So in terms of a, what does the ratio of a over c equal? In terms of a, Shatise?
Sine.
Yes. A over c in that triangle is sine. So we'd say sine squared of a plus, what's in terms of a, what does b over c equal? Nina? Cosine. Cosine squared of a is going to equal to, wait, I said equal a. It should have, this should have been equals 1. It equals 1. C squared divided by c squared is 1, so that equals 1. So we have solved that trig identity, all right, using the right triangle. All right, now we're going to verify those two theorems, right? So the first we have to show that the sine of a divided by cosine of a equals the tangent of a in terms of a 3, 4, 5 right triangle. So we would have the sine of a over the cosine of a, right? In this triangle, what does the sine of a equal? Ben, in terms of numbers. In the picture, what does the sine of a equal?
3 over 5.
Yeah, it's 3 over 5. What does the cosine of a equal? Lexi? 4 over 5. We divide 3 over 5 by 4 over 5, that equals 3 over 4, right? Which is, in terms of a, that equals to the tan of a. Questions? All right. So now we have to prove the other one. That we have to show that the sine squared of a plus the cosine squared of a equals 1. So the sine squared of a would be, we know that the sine of a is 3 over 5, so it would be 3 over 5 squared plus the cosine of a is 4 over 5 squared. That equals to 9 over 25 plus 16 over 25, which is equal to 25 over 25, which is equal to 1. Right? Equals 1. Okay, any questions? No questions. Okay? Okay, given the sine of a equals 0.5736, find the cosine of a. We're going to, so which trig function or trig identity could I use of these last two? Shatise?
Sine squared a plus cosine squared a equals 1.
Yeah, I can use that one. So we're going to use sine squared of a plus cosine squared of a equals 1. So that's going to be 0.5736 squared plus the cosine squared of A equals 1. So that's going to be solve for cosine squared of A. So cosine squared A is equal to 1 minus 0.5736 squared. So the cosine of A would equal to the square root of 1 minus 0.5736 squared. And so cosine of A equals approximately to the nearest 4 decimal places. What does cosine of A equal? Caitlin, what'd you get? Yes, speak up. Alright, she didn't have a calculator. So, Emma, what'd you get?
0.65.
Nope. Zach, what'd you get?
0.8191.
Yeah, you should get 0.8191. I'm not sure where you went wrong, Emma. You know, you'd have to. So you'd enter square. You would do cosine -1 No, we just found the cosine of A. So you do the square root of 1 minus 0.5736 squared. You should get 0.8191. You want me to come over and look at it, or did you get it?
I got it.
You got it? Okay. Anybody else need help? All right. So now we're going to solve a right triangle. Solving a right triangle means finding the measures of all of the angles and all of the sides of the triangle. So, we're going to solve the right triangle ABC. All right? So, what do you think the easiest thing and the first thing we could do to find the angles and all the angles and sides of this triangle? Shatis.
We could first find angle B.
Right, we could find angle B. So we have angle A plus angle B plus angle C equals 180. So we would have 43 degrees plus angle B plus 90 degrees is equal to 180. So then we solve for B. Angle B equals 47 degrees. So we've got B is 47. How about finding side A? What could I use to find side A? Jordan.
The sine of 43 degrees.
Yeah, sine of 43. A is opposite, 14 is the hypotenuse, so we could do sine of 43 degrees equals A over 14. So that gives us A equals 14 times the sine of 43 degrees. So A is approximately, what do you get to the nearest 4 decimal places? What did you get for A? Chatis.
I rounded up for this 9.547. Wait, no, 9.548.
Yeah, it'd be 9.5480, and then let's say we're going to round that to the nearest hundredth, so that'd be 9.55. I'll specify the rounding. I know I'm kind of vary on what to round to. It doesn't say here, but find your initial number out to the 4 decimal places and then round to whatever it says. Okay? How about cosine, or not cosine, how about B, side B? How could I find side B? Nick, how could I find side B?
You could find the adjacent over the hypotenuse.
Mm-hmm.
Use the cosine of B.
Yeah, cosine of 43 degrees would be the adjacent is B. The hypotenuse is 14. So then we have B equals 14 cosine of 43, which is equal, so B is approximately, what do you get? Yep, Nina? 10.2390. We'll round that to the nearest hundredth, so that'd be approximately 10.24. Alright, so we have solved that triangle. We found the missing angle and the 2 missing sides. That's solving a triangle. When they ask you to solve a triangle, find all the missing parts. Shatis.
But you have used sine 47 to solve for B?
Yep. Sine 47 of B would be the same, to solve for B would have been the same as the cosine of 43. Solve this right triangle. Alright, so where do you want to start? Jordan.
To find angle A, you can do tan of A equals 7/9.
Okay, so we could do, to find angle A, we can do tan of A. Tan of A equals 7/9. So tan, that's going to be inverse tan. Tan negative 1 of 7/9 equals 37.8750. So A equals 38 degrees. I rounded up. Right, so if A is 38 degrees, what else do we know? Shatis?
Angle B would be 90 minus 38.
Right. Angle B equals 90 minus 38 degrees, so that's going to equal to 52 degrees. Alright, and then how about side C? How could we find it? Chris, how would I find side C? We could do sine. What's another way we could do it? Shatis.
Pythagorean theorem.
Yeah, let's do Pythagorean theorem. So we'd have 7 squared plus 9 squared equals c squared. So that's 49 plus 81 equals c squared. So 130 equals c squared. So c equals approximately 11.4. Questions on solving triangles? No questions. Okay. One more example. All right. So we're going to determine the area of ABC in the figure, given angle A is 50, AB is 35, and AC is 75. Okay, so if we had to find the area of this triangle, we need to know the height, right? We need to know the height of the triangle, H. How could I find H? Madeline Cherry, how could I find H? And that'd be two unknowns. Lord Jordan?
You can do the sine of 50 degrees.
Yeah, we can do the sine. We could do sine of 50 degrees is equal to h over 35, right? So then we have h equals 35 times the sine of 50 degrees, right? Which is approximately, solve for h, we get, Shatis?
And to 4 decimal places, you get 26.8116.
Okay, 26, let's just say it's 26.81. It's approximately 26.81. Right, and then I would do, we could do area. Area equals 1/2 base times height. So that's going to be 1/2. My base is 75, and my height was 26.81. So I'm going to get approximately 1,005 centimeters squared. Now, this, what we just did, okay, can be simplified into a standard equation. Okay, that equation is area equals 1/2 AB sine C. AB sine C. That's the same thing we did. We found that this is your B sine C, and then the 25 would be your A, right? So it's 1/2 AB sine C. So I can, if I have, this is called the side angle side area theorem, right? So you can either, if you don't remember the formula, you can break it down like we did it, solve for h, then plug in, or you could just take this, you know, if I just plugged in here, okay, this would be, this side would be A, this side would be B, and this would be sine the angle C. So we would just plug in, we'd have 1/2, A would have been 35, B would be 75, and then we do sine of 50 degrees, and I'd get the same answer. It's the same thing we just did, just not broken down into as many steps. So that's something you can commit to memory. AB sine C. C has to be the included angle between A and B. So that's a area formula you can use. Any questions? Shatis?
I don't know if I might have done it wrong, but you get slightly different answers. Like if you go to the decimals.
The decimals were a little different. All right, but it would have rounded to 1005.
Yes.
You're good. Okay. Any questions?